Jai Hind everyone. Welcome once again to your mathematics class. As from past few videos, we all are discussing about the class 9th 4th chapter, linear equations in two variables. Till now, what we have discussed in the previous videos were about the linear equation in two variable, then finding the solution of equation, writing it in standard form, drawing the graph of a linear equation in two variable. Now, in today's lecture, we all are going to talk about the equation of lines parallel to the x-axis and the y-axis. It is the last topic of this chapter. So you all might have seen sometimes in a Cartesian plane, you get a line which is either parallel to x-axis or parallel to y-axis. So about those lines we all are going to discuss today, that how the lines are formed, why those lines are there, and what are their importance. Now in the previous chapter you all have studied how to frame a Cartesian plane, and in that how to plot the points. Now consider a Cartesian plane and think about these points. Say the point is 2 comma 0, another one is say minus 3 comma 0. Let's take one more point as 4 comma 0. Now can you all guess that where all these points lie? Yes, all these point lies on the x-axis. In fact, any number of the form of n comma 0, any coordinate of the form of n comma 0 where n is a real number will always lie on x-axis, because on the x-axis the y coordinate is always 0. So from here, can you guess the equation of x-axis? The equation of x-axis is y is equals to 0. Why? Because we have just now observed that all the points on an x-axis have y as 0. If you wish to write this as linear equation in two variable, it can also be written as 0 times x plus 1 times y is equals to 0. This is how it can be expressed in the form of two variables. Similarly, if we talk about the points, say 0 comma 5, 0 comma minus 2, 0 comma 3, all these points will always lie on y-axis. Now here you all can observe that their x coordinates are 0, which means the equation of y-axis is x equals to 0. In form of two variables, we can write it as 1 times x plus 0 times y is equals to 0. So this is how we can write down, or we can find out the equations of x-axis and y-axis. Now what if I'll take an equation x is subtracted by 2, that means x minus 2 equals to 0. Now if I'll take this as an equation, we will get its solution as x is equals to 2. And if I have to represent it geometrically, we all know that we represent it with the help of a number line, which you can see is over here. X is equals to 2 is here. So this point will represent the solution of this equation if we consider this as an equation of one variable. But what if I express it as an equation with two variables? An equation with one variable has a unique solution which we have already studied in our previous class. An equation in two variable, like if I have to write this in the form of an equation in two variable, then I'll write it as 1 times x plus 0 times y minus 2 is equals to 0. This is how we write it in the form of two variables. And now, since it has become a linear equation in two variable, it will have infinitely many solutions. That means it will have infinite number of solutions. Now, if I have to draw the graph of this, what should I do? We have to frame a table. In that we will put different values of x and y. Either will put the values of x or the values of y to get the corresponding values of either x or y, and we write it in the form of ordered pair. Now we know one thing over here. What is that? Say it is x, this is y, the ordered pair is x comma y. We know that here the y is multiplied by 0, which means you put any value of y, it will always gives x equals to 2, because any value of y substituted over here multiplied by 0 always gives 0. So here we will substitute different values of y to get x. So if I'll put y as 0 in this equation, remember I am talking about this equation. So if I'll put y as 0, what will I get? It will be x plus 0 minus 2 equals to 0, which gives x equals to 2. So the first ordered pair will be 2 comma 0. Same way, if I'll put y as say 2, if I'll put y as 2, then also I'll get the value of x as 2, because 2 into 0 makes it 0 once again. So the second ordered pair will be 2 comma 2. If I'll put y as say 4, then also I'll get the value of x as 2. So it becomes 2 comma 4. So we have got these 3 points, and let's see what we will get if we'll plot these points in a Cartesian plane. So the points are 2 comma 0, 2 comma 2 and 2 comma 4. So let's plot the points over here. The first point was 2 comma 0. So this is the first point. The second point was 2 comma 2. So here it is, the point 2 comma 2, and the third point was 2 comma 4. So here the third point is, that is 2 comma 4. Now what you can see, if I'll draw a line or a ray joining these points, so then what will I get? You can see what I am getting is a straight line. And if you want to see, you can see that it is the equation which representing x equals to 2. So the equation which was already represented in the form of a linear equation in one variable, when transformed in the form of a two variable and drawn the graph by finding its solution will gives us a line which is parallel to coordinate axis. Either it will be parallel to x-axis or it will be parallel to y-axis. This was an example where it is parallel to x-axis. Similarly, if you have a question say y minus 2 equals to 0, in that case you will get a line which will be parallel to y-axis. Sorry, this one was the line parallel to y-axis. In the other case, you'll be getting a line which will be parallel to x-axis. That's how we can represent the graph of a linear equation in which you will have only one variable by transforming it into two variable in the Cartesian plane. So this is how we can do. Let's take one more example for today's class. Let's take another question. It is given in NCERT example. It says solve the equation. The equation is 2x plus 1 is equals to x minus 3. The question says solve this equation and represent the solution in two ways. The first one is on the number line, and the second one is in the Cartesian plane. So this is what the question says, that you need to solve this equation first, and then we need to represent the solution first on the number line and secondly in the Cartesian plane. So firstly, what we'll do, we'll try to do it on the number line. So we'll simply solve it. So the solution will be like this. We all know that it's quite simple. We'll shift the variable on one side, constants on the other side. So it gives us 2x minus x is equals to minus 3. Plus 1 will come to this side, becomes minus 1. So 2x minus x becomes x is equals to minus 4. So that's what the solution of the equation is. Now if I have to represent it on the number line, you can see over here we have already having a number line and minus 4 is over here. So this point will represent the solution, that is x is equals to minus 4. So that's how we do it on the number line. Now what if I have to represent it in the Cartesian plane? So first of all, what we need to do, we need to reframe it in the form of a linear equation in two variable. So let's do that. So x equals to minus 4 can also be written as x plus 0 times y, because y is missing, and when this minus 4 will go to this side becomes plus 4 is equals to 0. This is the standard form of a linear equation in two variable. Now what we need to do to represent it in the Cartesian plane, we need to frame this equation, reframe this equation in the form of x equals to something, and then we need to find three different solutions. So we all know how to find the solution, so I'll just write three different solutions for the equation and then I'll proceed. You all know how to do it. And in the previous classes, as I mentioned, that most of the time we put the values of x to get the different values of y, but these are certain special cases where we will put the values of y to get the value of x. The reason behind the same is because here the y can accommodate any real value, whereas the value of x is independent of y. So that's why we'll put different values of y. Let's put y as 2. When I'll put y as 2, I'll get x as minus 4. So the ordered pair will be minus 4 comma 2. If I'll put y as 4, I'll get x again as minus 4. So minus 4 comma 4. And if I'll put s as minus 1, it again gives us the value as minus 4 only. Here I have not shown the solution steps because in our previous lectures we have done it in a very detailed manner that how to find out the solution of this equation. So we have got three different points. What we are going to do now is to represent these points on a Cartesian plane, and then we'll draw a line passing through all these 3 points. So let's minus 4 comma 2, minus 4 comma 4, minus 4 comma minus 1 are our points. So let's take a new page over here. So what we need to do is to plot the points. So the first point was minus 4 comma 2. So let's plot minus 4 comma 2. So here is the first point, minus 4 comma 2. The second point was minus 4 comma 4. So it is minus 4 comma 4, which is coming over here. And our third point was minus 4 comma minus 1, which is coming over here. Now what we need to do, we need to join these points to draw a line. So here it is, and if we want to see that what does this represent, it represents x is equals to minus 4. So I hope this must be clear to you all. With the help of this, you all can solve the exercise 4.4. Contains only 2 questions. Let's get a quick revision what we did today. We have talked about equations of line which are parallel to x-axis and y-axis. How to find out the solution of these equation. If it is containing only one variable, you can find its solution, and it will give you a unique solution which can be represented on a number line. If the question says to draw it in the Cartesian plane, we reframe it in this form, find its 3 solutions, plot these points in the graph, and then join the line passing through those 3 points. So we have taken another example where we have solved this equation. Whenever it says on number line, we simply have to solve it and represent it on a number line like this. When it says that you have to represent it in a Cartesian plane, reframe it in this way, find 3 different solutions, and then plot them in the Cartesian plane the way we did over here. So that's all for today's class. Solve the exercise 4.4 with few extra questions. For one more time, we all will meet in the next class. Till then, happy learning. Jai Hind.